Hello guys, welcome back to my channel. So today we'll be discussing about um, equal sets. So what do you mean by the term equal set? So here equal is nothing but anything in equality, correct? No? So here whenever I talk about equal sets, there will be a comparison between two sets. So if there is a question based on equality of sets, then you will have two sets given. So for example, if I have set A is equal to 1, 2, 3, 4 and set B is equal to 2, 1, 4, 3. So now I have set A 1, 2, 3, 4. Set B also I have 4 elements, that is 1, 2, 3, 4 itself. But when I've written set B, order of elements I have not considered. I have not taken into consideration. So I think in my previous videos also I have mentioned it very clearly that whenever I write a set, all the elements should be present. But in whenever I write a set or represent a set, order of elements is not mandatory. Okay, it is not at all. It is not mandatory to follow that after 1 2 only has to come or after 2 3 has to come. So here order of elements does not matter, only elements which has to be present inside that set. If it is present, it is more than enough. Now I have set A is equal to 1 2 3 4, set B is 2 1 4 3. So which means set B also consists of 4 elements 1 2 3 4. So when I have both the elements, so both the elements from two sets same. See, I have 1, 2, 3, 4. Set B has 1, 2, 3, and 4. When I have same number of elements in both the sets, then I write set A is equal to set B. Okay. For another example, I'll give you different varieties of example. This is for equal sets. Equal sets. Okay. So I'll give you another example. I'll take consider set C is equal to A, B, C and set D is equal to A, B, C. I have two sets, correct? So here set C is ABC, set D is also ABC. So since I have all the elements of set C and set D to be having the same number of elements or the same letters consisting of set C and set D. Yeah, so I can tell that set C is equal to set D. Okay, so in for example, if set D would have been for example B, A, C, this also would have been an equal set. Why an equal set? Because in set theory, what does not consider cardinality? Cardinality is not right. No, not cardinality here. We'll talk about cardinality once I finish with this. Here, whenever I talk about equal sets, order of elements does not matter. Okay, please bear that in mind. If you bear that in mind, no, you will never go wrong in questions based on equal sets. I'll give you another example. Yeah, we'll also talk about cardinality here. Since when I talk about equal sets, we are counting the number of elements inside a set. Correct, no? So when I count the number of elements inside the set, obviously counting will be applicable only to a finite set. So here I can also sorry. So here I can also find out the cardinality of set. So cardinality of set A is n of A is equal to 4. Why 4? Because there are 4 elements inside that particular set. Similarly, cardinality of B is equal to 4. Okay. So there are certain cases in which cardinality of two sets would be same, but elements are not same. So in that case, will my set be equal? So I'll give you an example. I'll again consider set A is equal to 5, 6, 7, 8 and set B is equal to 5, 6, 9, 10. I'm giving you varieties of examples. I know here cardinality of set A is equal to 4. Why cardinality of set A is 4? Because there are 4 elements inside the set and I am able to count there are only 4 elements inside the set. So therefore n of A is equal to 4. Similarly, I have n of B also equal to 4. But if I have both the cardinalities same, can I conclude that both the set are equal? Both the sets are equal? No, right? Because I don't see elements 7 and 8 in set A, same 7 and 8 to be present in set B. Correct, no? So what does it mean? Here, set A is not equal to set B. Though cardinality can be same, but until and unless I get the same number of elements in set A and set B, I will not have an equal set. Though my number or count in both the sets might be same. Count is nothing but cardinality here. So I think this is clear. I'll give you a few more examples for that matter. So example number D. If I have set D is equal to AB and set E is equal to A, B, C. Are these two sets equal? No, right? Because cardinality of set D is equal to 2, I have cardinality of set E is equal to 3. We already know that if cardinality is same, do I conclude that it is equal? No. Yeah, because I will have to check for the number of, for the elements, physical elements. So I have A and B, these are the two elements. Similarly, in set E, I have the same elements A and B, but here C is also getting included. So therefore, D is unequal with set E. Now it is clear, I believe. So I'll give you one more example. Again, I'll write set A is equal to A, E, I, O, U. Again, I write set B is equal to U, O, E, A, I. I can tell set A is equal to set B. Here cardinality n of A is equal to 5. Similarly, n of B also is equal to 5. In this case, both cardinalities are same. Elements inside the set are also same. So therefore, I come to a conclusion that it is an equal set. Set A is equal to set B. To summarize what is an equal set, please look for the elements inside the set. If there are same number of elements, okay, it does not mean that it will be an equal set. Okay, same number of elements will only be helpful for you to tell whether what is the count of that particular set. To tell what is the cardinality of set, that number of elements will matter. But please check for the variety, whatever letters or whatever numbers are there inside the set. Are they same for both the sets? Whenever I compare two sets for equality, what do I don't see? I do not see order. I can reshuffle and write any number of element inside a set. Okay, so hope this concept of equal sets with few examples is clear to you all. You can resume, pause, listen to the explanation as and when you require. Hope this concept is clear. Please make your concepts clear. Um, hope this is understood. Thank you all.